Thank you all for joining us. Good morning and welcome to today's seminar hosted by Mel Foster and Crowley Associates featuring Panasonic. Everyone is muted, so please feel free to type any questions you may have into the Q&A tab. Your questions will be monitored and I will provide answers either during the presentation or at the end as it works out based on your questions that you have. We are recording the seminar, and I will send out a link to that recording along with the slide deck to everyone attending in the next few days. So I will now turn the meeting over to Brian to get things started.
Hello, everyone. Thank you, Robin. Good morning, everyone. Thank you very much for joining. Thank you for taking the time and joining us today. We all know that your time is very important.
Next slide.
Robin, if you can move, or someone can move over to the next slide, please. Thank you. Just so you guys are aware, what I'm putting up here is just a high-level overview of some of the products that Panasonic has. We show this often because a lot of times customers forget that we have some of these products. But this is just up there as a high-level overview. What we're actually going to talk about today is we put together an actual application overview around power management. And what we did is we backfed it with the products that the industry leaders like yourselves are using for those types of applications. So, using many of the products that you see up on the screen now. But the purpose of this overview is just to kind of show you some of the bleeding edge technologies that we're using. And it's unfortunately, it's just, with the time that we have, it's just a short teaser, but we are more than happy to follow up with a call or a visit. If you just reach out to your rep and the Panasonic people would be more than happy to discuss. As Robin said, I will be monitoring the questions and the Q&A, and we can, but if you have anything you want to put, you can certainly put it in the chat and we can address it at the end. But other than that, we wanted to take the time again. Thank you again for attending the seminar. And the purpose of this is just to get the ball rolling so we can have a follow-up conversation. So please reach out if you have any questions. The presenters are going to go ahead and introduce themselves so we can move on from there. Thank you very much.
Thank you, Brian. Hi, I'm Eric Johnsrud. I'm the product manager for our passive components. I'll be covering our capacitors and inductor products. We're going to start with our hybrid capacitors. So our hybrid capacitors are pretty much the best of both worlds between electrolytics and polymer capacitors. So they have the high reliability of the lytics while also having the large current capabilities of the polymer. So this works by having a mixture of an electrolyte and a polymer inside the capacitor, so that it gives you the advantages of high voltage, high temperature, and low leakage current, while also having low ESR and being able to be small size. These parts work better than polymers in high humidity with also low leakage current, and they have an open failure mode for safety and reliability. This is our lineup for our hybrid capacitors and what we're expanding in. So we're focusing in two areas, larger capacitance with higher ripple, and then longer life with higher temperatures. Most of these parts also come in an anti-vibration, which I'll cover in the next slide, but we've been expanding our different areas to have these higher capacitances as well as these higher temps and longer lives. So with our vibration, this is not only to our hybrid capacitors, but we also extend this to some of our lytic capacitors, but these are our vibration proof. We have three areas that strengthen our capacitors for this. One is the supporting terminals. You can see that in the bottom right of the picture, where we have a supporting structure so that the terminals are built into the base plate, so they have a better solder joint and a bigger area to maintain contact. The next one is the high walls, which you see next to it going to the left, which these higher walls help keep the capacitor from vibrating in place. And the last one is a larger diameter lead wire versus the standard products. So this gives them a wider part so that it doesn't have a failure point compared to the standard part. Now on to our film capacitors. These are some of our main focused or best area film capacitors that we have. So for AC filtering, we have our EZ-PQ series. And then for input smoothing, we have EZ-PV series, which has a large capacitance. For input and snubbers, we have our ECW-FG series, which has two different varieties. We have a high current type and a compact type. So throughout all of these, we have a lot of different products for DC and AC applications. So this is kind of going a little bit more detail of our film capacitors and where they kind of fit compared to other types of technology. Our best area for film capacitors is 450 volts to 1,500 volts with 1 microfarad up to 100 microfarads. We have a wide range of power values that can support this, and these are not polarized, so they're good for AC applications. They have a better aging process compared to other capacitors such as electrolytic, so they can have a much longer life, and they have low ESR, which gives a result of a low dissipation factor. So these parts were very focused in this one area, but we also can support outside of that if your requirements need that. But this is our best area, so if you have an application that needs something there, we have a very good film cap for that. So another key feature of our film caps is our safety metallization pattern. So what this is a fuse function that we build into the metallization pattern so that there is a breaking point if it has a short. So instead of the entire capacitor breaking and causing a short circuit, these fuses will break apart, causing the capacitor to open on failure. So instead of having an immediate failure, this has a more slower long-term failure because each section is separated. So as the failures happen, the capacitance will go down, but the capacitor will still continue to function until most of the fuses have failed, and then it will fail open, causing a circuit to not cause a burning sensation. So some of the applications that we have our film caps in are DC fast charging. So you can see that our different types of film caps can be used across the input filters, the output filters, throughout the different stages of the DC to DC conversion and the AC to DC conversion, as well as the rectifiers. And then another application is AC to DC wall charging stations. So again, we have a lot of different film caps that fit into this different areas. So input, we have our ECQ UA and UBs, our X2 and Y2 film caps. And then you go into the EZPBs for filtration. So there's a lot of different film caps that can be used in a lot of different areas. Now on to our inductor products. So these are our power choke coils. So our inductors are all AECQ 200 qualified. They all use a metal composite material. And a nice fun fact about our film caps, our inductors, is that once we've released these into the market, we have not seen a single field failure since 2014 when we came out with these. They are very reliable for all of our automotive applications, and we have a lot of different types of series. So our MC series is good for high performance. Our LP series is a low profile, and LE is another performance. And our LP and LE series are also very nice because they have the same type of footprint as some of our competitor parts. So if you were looking for a second source that you need, these parts could work as an option for that. We also have our large current, vibration proof, and high frequency types as well. So here are some of the advantages that our metal composite have versus a ferrite type. So essentially for DC bias, as you start getting into higher currents, our parts have a very linear curve where a ferrite type will start to fall off once you go above 1 amp. Also, the frequency response for AC current, we have a better handling of that compared to the ferrite types in the high frequencies. For acoustic noise, for some of our anti-vibrations, because of the metal composite structure, there's less ability inside of it to cause vibrations, so you get a lower noise for when it starts creating issues. And then also for downsizing, we have a lot smaller size packages compared to the ferrite types with higher performance capabilities. So you could have a smaller space requirement taken up from these parts. Here's just a slide kind of going over some of our LP series as these line up to some of our competitors. We have a wide offering of different inductances, DC resistances, and rated currents so that you can find the right size for what you might need. And then here's an example of a usage of some of these. So these inductors would be used in battery chargers or DC to DC converters for a lot of this areas to work as an input-output filters and help with those converters. And with this, some of the replacements to the ferrite types is that you can have higher performance in these parts, as well as downsizing so that you can fit more parts in a smaller area. And a lot of these, as I was mentioning, a lot of these are automotive qualified, so they can be used in very robust applications because they are ruggedized and meant to withstand a lot of harsh environments.
Hi, my name is Jeff Katz. I'm the product manager for our industrial devices group. And so for today, I'll be covering our relay products. So Panasonic has a very wide relay offering. We have anything we consider mechanical into two different categories, power and signal. We consider power to be anything that's more than 2 amps. So we'll be focusing in the power area today. And then we also sell solid state type relays as well, which we call PhotoMOS, which are MOSFET controlled relays. And I'll be introducing that a little bit towards the end of the presentation. So a lot of our newer mechanical relays in the power area, we call them energy management type relays. And the market that we're going after is higher power relays that were traditionally serviced using contactors or thyristors in some cases. And there are some inherent advantages of using a relay if you could replace a contactor. First is that all of our relays are PCB mounted, so you can just solder them onto your board much easier without the need for screw terminals or using wiring methods, which can take up more time and more labor costs. Also, relays tend to be smaller in size and can cost less compared to a traditional contactor as well. Lead times could be much shorter. And we also offer these relays with very low coil holding power. Usually, since the mechanical armatures are smaller than contactors, it requires less power to maintain the energized state, which is very important for energy management. So, sorry, can you go back one slide? So on the bottom right, the way that we are able to offer the lower power through the relay is using a coil holding technique. Traditionally, this is used PWM method, which is pulse width modulation. And so once the relays are energized, you can lower the coil holding voltage and still maintain the energized state. So this is a common theme within our energy management relays. They all have this pick and hold type coil solution. Next slide. So the first relay that I'll go over is the HES relay. This is a two-form A contact arrangement. So it has two normally open contacts, each that are rated for 35 amps at 277 volts AC. And they can also carry up to 40 amp current as well. What's also unique about this relay is there's an auxiliary contact option as well, which is a normally closed contact that would carry signal. And so if either of your normally open contacts weld, you can design a safety circuit around the normally closed to know the position of your contacts because they are mechanically linked together. And so you have that added safety feature in there and can eliminate some redundancy relays and still meet certain safety requirements. So also, as I mentioned before, with the low coil holding power, once the relay has been energized, you can actually hold the coil in place, hold the contacts in place with only 170 milliwatts of power. Next slide. This relay here is similar to the previous. This is called our HER, and it's actually two of our HES relays in one package. So there's actually 4 normally open contacts with that auxiliary contact option as well. And we also increased the switching capacity. So instead of 35 amps, this one can actually do 40 amps through each of the contacts. It also has a much higher short circuit current rating compared to the previous relay. This one could do up to 3,000 amps. And that's important for certain applications, especially EV charging type applications as well. And again, it still has the low coil holding power, so you can reduce it down to 1 watt at 50% of the nominal coil voltage. Next slide. This is another variation, same package as our HER4A1B, which was on the previous slide. So the 4A1B is actually going to be released officially in April. This one will be released officially in June. And this one has actually 80 amps per contacts. It's only a 2-form-A with an auxiliary contact, but it does have a much higher current. Again, all the same features as far as low coil holding power. It's also PCB mountable relay as well. And then samples for this one is currently available now, and mass production will be in the summer. Next slide. This series is our HEPV relay series, and this one is currently in production with 3 different flavors. There's a 35 amp type, a 48 amp type, and a 90 amp type. And this is referring to the continuous carry current rating. And again, the way that we're able to maintain that these are PCB mounted relays is by using these wide blade terminals for the contacts. So the 90 amp has the widest blade. If you were to compare it to the 48 amp, there's another wide blade, and then the 35 amp has the smallest blade terminals. But they all have the same external dimensions. The contacts are a little bit larger on the 90 amp type as well, and that's how it's able to achieve the higher switching capacity. Again, these have very low coil holding power, and they also, all of the relays, including the ones I showed previously, have a wide contact gap as well. So I know that this is required for a lot of the higher voltage switching applications. So this one can switch up to 80 amps 277 with the 90 amp carry. And again, 480 milliwatts to the coil to maintain the energized state. This is our HE-A relay. This will also be released this summer. And this actually has the same footprint as the previous slide with the HE90 amp. What we did here was we actually added in an auxiliary contact, which we call a mirrored contact structure. So again, the auxiliary contact is mechanically linked to the normally open. And so you can judge using the normally closed contact the position of the normally A. So if there is some welding involved, you can use this. You could design a safety circuit to confirm it. And we also increased the carry current over the previous slide from 90 amp to up to now 100 amps. So pretty large current going through this size relay. And again, with a maximum holding power of 310 milliwatts. Next slide. And this is another product that's currently in our lineup. Right now, this is the highest current switching we have for our AC type relays. Everything I've shown so far was designed to switch AC. I'll show the DC type solutions in the next slides, but this one could do up to 120 amps. The main target market for this is really for mega solar inverters. But again, it also has an 800 volt AC switching capability as well, holding power of 400 milliwatts. Next slide. And I did mention all these relays that I showed previously, they are AC relays. However, if you do need to know what the DC ratings are, we have tested DC load voltages on each of these, and we could provide test reports as reference data for all of them. Next slide. So now I'll go into some of our DC solutions. We have a lineup of what we call EV relays. We've been producing these since 1997, mainly for the electric vehicle and hybrid and plug-in type markets. But these could also be used for industrial DC switching as well. And the way that we design these, the contacts are in a hermetically sealed chamber, which is filled with hydrogen gas. And so when the contacts separate, the electrical arc that's generated gets quickly extinguished by the gas. There's also a magnet inside the contact block as well, which causes the electrical arc to expand outwards away from where the contacts are, and that prevents the contacts from getting damaged. Next slide. And so all of our EV relay lineups, they're designed for 400 volt switching. And we have low current types from 10 amps, which are traditionally used for more of a pre-charge type application. And we go all the way up to the main contactor size of 300 amps. We did release a new series, which is the EV-A series. This is the one on the bottom right here. And that one's actually rated up to 500 volts DC. And there's also no polarity on the contacts as well. So there's no possibility to miswire them incorrectly. Go to the next slide. This is a closer look at our EV-A relay from a spec point of view. So you can see that it has a very short high circuit capability up to 1000 amps for 1 second. It's mounted with standard M3 screws. And then for the coil, it can be connected using a standard Yazaki connector. And we can provide the connector part number for that as well. But again, maximum cutoff is at 1800 amps, 500 volts DC for one operation without any contact polarity. Next slide. And now I just would like to go over one last topic. This is our PhotoMOS technology. So Panasonic is the global world's leader for this type of technology. And as far as energy management, we see these being used in battery management systems for detecting the amount of charge that's in a battery pack, and also for safety insulation as well to detect if there's any leakage current if the insulation deteriorates. And so the way that this product works, basically the input side is an LED, and each channel has 2 MOSFETs. So once the LED lights up, there's a photocell that absorbs the light and then charges the gates of the MOSFETs on the output side. Once it reaches a threshold voltage, the current can flow through the other end. And so the key advantages to this is without any mechanical moving parts, the life of these relays is theoretically infinite. The only thing that would degrade over time would be the LED. However, depending on what your input current is to the LED, we can make the lifetime last more than 20 years. Also, there's no sound of switching because there's no moving parts. And we're also able to get the package size much smaller as well, since there's no mechanical armatures that need space or any electrical arc that needs to be extinguished. Next slide. And these relays are also capable of switching both AC and DC because there's 2 MOSFETs per channel. This lineup shows our switching capability, and you'll see on the energy management side, some of these can be used for solar and battery. For the highest current we actually go up to is 10 amps for these. If you do need to switch higher than 10 amp current, we do have MOSFET drivers. So you would basically get your external MOSFET, and then we can provide the driver side to it. And we could drive silicon carbide MOSFETs using some of our MOSFET drivers. Also, on the high voltage side, we do have up to 2000 volts load voltage as well. So if you do have a battery management system doing high DC switching, we can also use our PhotoMOS for those types of applications. And that's all I have to share for today. But if you do have any questions about any of our products, we'd be happy to answer them. And we also would feel free to engage with a further discussion, perhaps at a later time as well.
Thank you so much. Appreciate the great presentation and overview. I did just launch a poll. So if everyone would mind just responding to that poll, if you see any current or applications on the horizon that Panasonic might be able to help you with, we'd be happy to follow up with you. If there are any other questions, please raise your hand and we'd be happy
Rob?
to just let you have access. Yeah.
Robin, we have one question about sharing
Okay.
the deck.
Okay, good. Yes,
the question-
absolutely.
Yeah, sorry.
Yeah, no problem. We are recording this seminar, so I'll send out a link to that recording along with the deck to everyone that's attending.
Okay, thank you. One last question for Jeff. Jeff, there's a question in the chat about if we have a three-phase solid state relay, 600 volts up to 50 amps.
Unfortunately, we do not have that in our
Okay.
lineup.
Thank you. Any other questions? You can put them in the chat real quickly. Otherwise, like I said before, you can certainly reach out to the account manager representing Panasonic, and we'd be more than happy to get together, either on a phone call, some exchanging some data over email, or we can discuss over a visit. Thank you, Marcel. Robin, I don't think we have any other questions.
Okay, well, thank you everyone for your time. We appreciate you participating. I'll send out that email to you in the next few days, but hope everybody has a wonderful day. Take care.
Thank you.
Thank you.
Thank you.
Thank you, everyone.